Hello everyone, this is Matthias Lux and I'm presenting to you our contribution to MMVE 2020 about how players play games, observing the influences of game mechanics. That's joint work of 4 people that work at Klagenfurt University in Austria. It's Philipp Moll, Veit Frick, Natascha Rauscher and me, Matthias Lux. Okay, let's walk through our contribution. Basically, first you need to understand how successful games evolve. So we are currently in the state that we have these perpetual beta things where games are getting better throughout. So you release it early with only part of the game working, and then you balance the game, you change the game mechanics, you do different changes, and the game gets better and better. So with the example of Fortnite Battle Royale, we actually take a look at the map. And these were the early hotspots, in early 2018. So that's where all the action took place. That's the blue dots on the left-hand side. That's 2018, early 2018. And as you can see, they changed the map a lot. So there are new islands. It looks a little bit different, but also the places on the island changed. And also the hotspots changed. So there's much better distribution of player activity on the late 2019 map. So it's 1.5 years at least in between, early 2018 to late 2019. Let's assume it's 1.5 years. And those small changes, continuous changes, were made to utilize the map better, to make the game different, to make the game better, to make it interesting. So all in all, those multiplayer games are hugely popular right now. So Fortnite on mobile alone made within 1.5 months $50 million. Okay, so actually Epic, the company behind Fortnite, they concentrate now on development of the Unreal Engine and the development of Fortnite, because Fortnite is actually their cash cow. So along with the game, they developed the engine, and all the other games they have developed, they have stopped working on it, like Paragon and Unreal Tournament. So those are kind of dropped, and all the assets moved to the Unreal Store for the Unreal game engine, and they work on Fortnite. Good game mechanics are actually the key towards a successful game. So if the game mechanics suck, so that your action you take in the game doesn't trigger a reaction, and you can't control this relation between action and reaction, you don't think it's a successful or good game, and it won't be a huge economic success. Especially research like we do in academia is hard on game mechanics because there's a lot of proprietary code. There are very few open source games, and virtually none of them is actually popular. There is no access to server logs or internal data, of course. Especially with multiplayer games, we can only hack the local game data, the local game, but not the server. We can monitor the server communication, which we already did, but it's mostly encrypted to shut out cheaters. And there is scarce cooperation with game companies in some research areas, but not much. So I know of many projects with the game industry, but they're very specific. They deal with people that the game industry knows in academia, and the other way around. You have to build trust first. There's no open data. There's no open approach for people trying to enter research on game mechanics and games in particular. So research on games should become easier, and that was our idea. That's why we did this work, and that's why we present the paper. So Fortnite Battle Royale is from Epic Games, as I already said. It's a combination of a first-person shooter where you run around and try to eliminate the avatars of other people, and a tower defense. So you build your own fort or your own barricades and hide behind them, build them newly, and so on. The game is actually following the scheme of a thriller, so it tries to tune down on a very local spot when then the final players meet in a very small, very dense final fight. So the large map gets reduced by a storm, and the eye of the storm, this is where you don't get any damage while staying in, gets smaller and smaller. So 200 seconds of storm brewing, then people have to move towards the storm, eye of the storm, then 180 seconds of construction, then these phases get smaller and smaller, like 150 to 90, 120 to 90, and so on. So that's what it looks like. So it's a screenshot. On the left, you can see the border of the storm's eye here, the blue thing, and you can see the storm brewing here in the background. This is actual footage from 2018 from the game. It looks different right now, but that's what at that time. Okay, so what does it look like? Let's take a look at the game itself. There's a video. So the game itself starts on an island where there's no fighting allowed, and people enter a bus, and then you basically jump out of the bus. It's the battle bus. I'm sorry, it's a German video. I've taken it on the PlayStation and forgot to turn it to English. Then you jump down and choose where you actually land. So that's the landing spot. You can see others. There's one other person jumping down beside me, and we basically open up a landing parapet and then jump here on the roof. You can see the others, and everybody is an enemy. So on the right hand side here, you can see the minimap, and it will start to show the storm outlines after this timer went to 0. Then you can move to the storm. Here we got some loot. You start with nothing, but now you get ammo and weapons and shields and power-ups. And well, those symbols show you stuff like what time it is. So that's the setup time. Then there is the storm brewing time and so on. And the numbers show you how many people are there. So yeah, there are only 87. So you see it's getting less and less. There's a shotgun. Maybe I should get the shotgun here. And here is how many people were already killed. Those are the loot boxes. They're pretty cool. So that's a golden minigun, which seems to be a big thing. Okay, let's jump a little forward in the video. Let's go here. So now you can see on the minimap there's a line, and the line goes towards the eye of the storm. So you have to move along this line. In 2 minutes and 15 seconds, it will start to contract. Okay, so some shooting going on, and basically you walk around. Let's see if we can find the eye of the storm somewhere. Yeah, it should be here. You see there's some building going on, and people should basically get inside that before the time runs out here, and kill everybody else. So there are only 46 people left, and the game goes on and on. Okay, so if we want to do research on the game, we actually require data about player interaction. And the video screen is pretty cool because the video I showed you, you can see all the interactions of the player, or actually the results of them in the video, so the visual response. You could hear the audio response. I just turned it off to be able to talk over it. But you can extract it from there. It's not the same as you would record every keystroke, every mouse move, but it's better than nothing. And game video streams are actually pretty popular. So there are a lot of videos available on YouTube, Twitch, and Mixer, which you can download, and then investigate the interaction of the players afterwards. However, the data from the video stream still has to be extracted, and that's a little bit of the problem. But that's where our toolchain comes in. So we take those streaming servers like YouTube, Mixer, and Twitch, take the video streams, do the movement traces, and then find the hotspot, the heat map and the hotspots where people were moving around. So those are individual, and from those we can actually compute the heat maps. In our user study we did to show that our toolchain works, we actually created those video streams manually. We let people play in a controlled environment, in a lab environment, and then let them do a survey. And our results then came out of that. But this video stream analysis toolchain is available and open source. So how did we actually do that? So the most important thing for player movement data is this area here. So you can see the player, the way the player, the direction the player looks here with the red dot. I'm circling it. And here you can see the player count and the current game status, which is here. And the player position relative to the game world is actually this minimap. So it's a cutout from the actual map, and the player is always in the center of this minimap, and the minimap scrolls around the actual map. So if you have the actual map, you can match where the player is with this template. And that's basically our idea. we first find the position of the icons, those icons here. Here we got it. So here is the storm brewing, I think. And we know which phase it is. Okay, then from this icon, we find the position of the player count, which we actually extract, do some PyOCR magic and Tesseract magic, and then clean it up with heuristics. So the player count is monotonously falling because there can't be entering of new players in between the game. And if it jumps a rapid succession down, then we actually check if we're wrong and can post-process it and see if we made any errors. The player position, we cut the minimap from the game stream and move it around. It actually moves around in the video streams depending on the platform, game state, streaming software, and the resolution of the players. Then we enhance the contrast with contrast-limited adaptive histogram equalization from OpenCV. We find the minimap in the overall map with the template match algorithm, also from OpenCV, and we clean up with the heuristics like maximum movement speed, water versus solid ground, and stuff like that. So the most common errors we found, we cleaned up with heuristics. So that's how it looks actually if we trace the movement data. So you can see players moving here in this nice little frame called frame from OpenCV, and we find the player on the map, and here you can see the red dot and it's having a tail. Then you can see the movement, and that's how we track it basically. Okay, so what can we extract? We extract the player position, we extract the number of active players, we extract the game phase, the kills, and the player position, and from all this data we can infer, for instance, landing spots, movement traces, death positions, win positions, final place, of course, active player progression, game duration, duration of game phases, and total number of players kills and killing positions, so where people actually get found and eliminated. So we applied the Toolchain to 4 hypotheses. So we investigated player satisfaction and enjoyment, if they are correlated by the player's success in terms of game round duration. We found a correlation there. Then the amount of time playing other games influences the success when starting to play Fortnite. We tried to find that out, but yeah, it doesn't seem like that. That's obviously too easy, so we couldn't support the hypothesis. There are frequently visited locations with only low killing activity. Yes, obviously there are, and that's something, if you find that out with the analysis, then you can do something about it, and that's the change of the game, kind of, make it better. The enjoyment of Fortnite beginners is influenced by the chosen landing spot, and that's pretty interesting. Yes, it is. If you land at a spot where you get killed immediately, people don't think it's fun. And if you find a spot where you can first loot and then try to set up a base, then that's actually more fun. Okay, we presented in our paper a toolchain for extracting player interaction from video. It works out of the box quite well. We needed some tuning with filters and heuristics to clean up common errors. With testing those 4 hypotheses, we showed the practicability of our toolchain, and we actually think it can be used to gain insight interesting for game designers. So what makes the games enjoyable, and how can players be steered towards more enjoyable games? In the future, we want to move on to other games. So there is not only Fortnite. It seemed at some point that there's only Fortnite, but it's not. There are other games. There's, for instance, Apex Legends from Respawn, which is targeted towards a little bit older players with a strong component of teamwork. So our toolchain can do something about that, but we have to check where the team players are. So that would be an additional problem. Or Counter-Strike Global Offensive, which is a very controlled environment, but also extremely interesting. And we want to infer more general rules for building enjoyable games. Okay, I hope you enjoyed the presentation and the video. All the code is open source. Again, I'm Matthias Lux. I'm Associate Professor at AU Klagenfurt, Alpen Adria University. And if you have any questions, this is my email address. And I think if I keep on talking, I'll just make it to the 15 minutes that are required for MMVE. Thank you for listening.